All right, ladies and gentlemen, let's get ready for the midterm. So we're going to look at the midterm review, which is really similar. I have version 2. You guys have the original. Okay, my version is really similar to yours, but it is slightly different on the numbers. But it's asking you to do the exact same things. Okay, for instance, the directions say show all work, circle all final answers, just like they do on your page. Numbers 1 through 5, no calculator. Okay, so all scratch work on 1 through 5. There will be a couple questions on the midterm that ask you to perform tasks without calculator as well. So, number 1, what is the decimal representation of 5/12ths? So I need to take 5/12ths, the fraction, and turn it into the equivalent decimal. What operation is a fraction? What operation is a fraction? Division. So I need to divide. What's really important about division? Something you got to keep an eye on with division. It is not commutative. Okay, so this 5/12ths says 5 divided by 12, which means 5 goes in the box and 12 goes out here on the left. Now someone's sitting there thinking, wait a second, you cannot put 12 into 5. And you'd be absolutely right. Try to remember what we do. We put a decimal point after the 5 and a couple of zeros. I'm putting 4 zeros. That should be enough. Okay, there's no hard rule about how many zeros you need to put. But remember, this decimal point that you put right here needs to come straight up in your quotient as well. Now you said 12 doesn't go into 5, and you're absolutely correct. So put a 0 in front of that decimal point. But 12 will go into 50. It'll go into 50 4 times, because 4 times 12 is 48. Subtract, okay, 50 minus 48, we'll get 2. And you can cross out the zeros and do the regrouping if you have to. That's fine. Now 12 doesn't go into 2, so we'll bring down to 0. And 12 will go into 20 one time. 1 times 12 is 12. Subtract, we'll get 8. Again, you can show the regrouping if you have to. Okay, 12 doesn't fit into 8, so we bring down another 0. And 12 will go into 8 6 times, because 6 times 12 is 72. And if we do 80 minus 72, we'll get 8. 12 still doesn't go into 8, so we'll bring down another 0. And 12 will go into 80 6 times, because 6 times 12 is 72. Subtract, we'll get 8. Now, hopefully at this point, recognize that this pattern is just going to continue. What do we call that when you have a decimal and the pattern continues? What do we call that, Yankee? Repeating. Okay, how do I represent a repeating decimal? We put a line over the part that repeats. So the decimal representation is 0.416, and that 6 repeats forever and ever and ever. So I put a bar just over the 6. Okay, not the 1, not the 4, just the 6. And there we go. Now, real quickly, if we did this on a calculator, it would give us 0.41666666667. Why is there a 7 on the end? Why would there be a 7 on the end, Kenny? Good. The calculator is going to round that last digit. It can't show the next one, so it rounds the last digit that it can show. The next digit would be another 6, which means the previous 6 would get rounded up to a 7. Okay? But we know that that 6 just repeats forever and ever. Okay? All right, number 2. What is the fraction representation of 0.375? This one's asking us to go the other direction. Okay? Well, if you think back to last year, there was a trick for how to turn a decimal into a fraction. 3 words. Start with R. All 3 of them. Anyone remember? How about read it? Write it doesn't start with an R, but it starts with the sound of an R. And reduce it. Read it, write it, reduce it. Okay? So how would you read that? And you're not allowed to say point. If you're not allowed to say point, how would you read that number? How would you say that number if you weren't allowed to say point? 375 hundredths? Thousandth. Okay? Thousandth. So you got 375 over 100? That's more than 1, isn't it? Is this more than 1? No. So it would have to be 375 thousandths. Remember? Tenths, hundredths, thousandths. Okay? Now, so we read it, we wrote it, and now we reduce it. So we can divide both of these. Well, there's a couple numbers that can divide. I can start nice and easy with 5, although that might take a while. How about I jump to 25? Okay, how many 25s can go into 375? Well, we could sit there and do the long division, or we could think about this. How many 25s fit into every 100? All raising 4 fingers, exactly right. Okay, 4 into every 100. How many hundreds do I have here? You can say it out loud. 3. Okay, so 3 times 4 gives me 12, plus 3 more to get 75 is going to be 15. Okay, How many hundreds in 1,000? How many groups of 100 fit into 1,000? You're getting ahead of the game. 10 hundreds in 1,000. Okay, every one of those 100 has 4 25s, which means my new denominator is going to be 40. You were just one step ahead of the game there, sorry, Nathan. Okay, now, I can reduce this just a little bit further. What divides both 15 and 40? 5. And if you divide those both by 5, what do you get? 3/8. Good. Is there anything that divides both 3 and 8? No. So, ladies and gentlemen, if you had right here stopped and given the final answer 15 over 40, you would receive partial credit because the final answer is fully reduced. Okay, you should never have a fraction for an answer that can be reduced further. Okay, always take it as reduced as you possibly can. So we're all the way down to 3/8. Okay? All right, number 3. Number 3. Louis practiced his trumpet for 1 1/3 hours on Monday and 5 6 hours on Tuesday. Both days he spent half of the time on scales and the rest of the time on songs. What fraction represents the amount of hours spent on songs? Okay, so here's what's going to happen. We're going to take time he spent on Monday, the time that he spent on Tuesday, and we're going to put those together. Okay, now that's going to give us the total time that he spent. But here's the catch. I don't want the total time that he spent. I want the time that he spent on songs. Well, they told us that he spent half the time on scales and the rest on songs. If he spent half the time on scales, how much of the time did he spend on songs? CJ? The other half. So if I want to know how much time he spent on songs, I'm going to take half of Monday plus Tuesday. Well, Monday, they said, is 1 1/3 hours, and Tuesday is 5 6 of an hour. So I need to add these together. Well, what needs to happen first? I've got a mixed number. So I need to turn that mixed number into an improper fraction. So I can use the old check mark method. Okay, 1 times 3 is 3, plus 1 more gives me 4. So I have 4/3 plus 5 6, and I'll eventually need half that. Well, what needs to happen with 4/3 and 5 6? Very good. I need a common denominator. So this 1/2 out here can stay. What's my common denominator between 3 and 6? 6. Which means 5 6 can stay. What am I going to have to multiply 3 by to get at 6? 2. Which means I also need to multiply the 4 by 2. And what am I going to get here? Dave? 8 over 6. So if I do 8 6 plus 5 6, what's that going to give us? 13 6. Okay? And I want half of that. How do you multiply fractions? You multiply straight across. So what's this going to give us when we multiply here? 13 over 12. Okay, now, they say what fraction represents the amount of hours spent on songs. Okay? So the fraction that represents the number of hours spent on songs is 13/12. But what if I wanted to make this a mixed number? What would it be as a mixed number? 1 1/12. How'd you get that? How did you get 1 1/12? Perfect. 12 goes into 13 one time, and then there's 1 left over. So that gives us 1 and 1/12. Okay? All right, so that's 1 through 3. We'll have other videos with the other questions on them. The questions on your review are going to be slightly different than these questions, but they're going to ask you to perform the same tasks. Okay? Thanks very much, guys. More videos to come.